Hello everyone, welcome to Code Guide. And today in this session, we'll discuss the topic retrieval for RAG, and we'll start with the implementation part. First of all, we'll get the OpenAI keys, import user data, mention OpenAI key, user data, or get OpenAI, and we'll get this keys in an environment. So import OS, web.environment, OpenAI, API key. Now we install the required library. So we have to install LangChain, then LangChain community. And then we'll OpenAI. Now we'll discuss the components of RAG. Component of RAG. First of all is document loader. To get the document loaded in document object, whatever may be the format, it may be PDF, text, CSV, Excel. So we have different types of document loader. To get the document, suppose we have PDF format, then we have to get the PDF format into document object where we have the page content as well as the metadata. So first one is the document loader. Second one is the text splitter to create the chunks of the document object or the page content so that we can pass these chunks and we will not get the error of the token limit. So for that we use the text filter. Next is the embedding model to convert the text into embedding. So embedding model. Next is the embedding model. Next, after creating embeddings, we need to store them. So we'll use the vector store. Then we have the retriever. After storing the embedding, when we ask the query will basically will try to retrieve the related context or document or chunks from the vector store, and for that we need the retriever, and fixed is the LLM. So these are the main components of RAG. We'll install the PyPDF as we are now going to deal with the document uh, in PDF format. So that will be the PDF for the PDF format, and we'll deal with the PDF document, which is the attention is all you need research paper, and we'll try to retrieve the document from that PDF. Okay, so give me a second. I will just get the PDF in a Google Colab. So I've got the PDF, that is the attention is all you need, and I'll just copy the path of the PDF. Now, first of all, we need to get the document, that is the PDF in our document object. So for that, I'll say from LangChain dot document loader import py PDF loader. Okay. Loader equal to py PDF loader, and I'll just copy the or paste the path, and I'll just mention doc is equal to loader dot load. Okay. So when I see this doc, you see we got the document object containing the metadata where we have the source of the file, the creator, the creation date, the subject, publisher, all the parts is covered in the metadata. Well, as the page content, yeah, from here the actual data in the PDF we get in the page content. Now we'll see the text splitter. So for token wise splitting, token wise splitting, let's say token splitter, and I'll mention the recursive character text splitter. First of all, we need to import it. So from LangChain dot text splitter import recursive character text. Now we have characters text splitter also. Now for that, it splits what we can say. It creates chunks according to the character. So that is a character level text splitter. And in case of and this is the most basic form of splitting, and it is not much used in industry, which is the character level text splitter. Now it basically separates when in character level text splitter, it basically separates by using paragraph, line, word, or character. So these are the separators which we can use to separate the tokens. first of all, we need to install the tick token. So pip install tick token. In the recursive character text splitter, we use the token wise splitting to make sure the token splitter. Token splitter is equal to recursive character text splitter, and from token encoder, I'll mention the chunk size. I had 50, suppose, and I'll mention the chunk overlap. Chunk overlap as 0. Okay, I'll create the chunk. Chunk is equal to token splitter dot set document, that I'll mention the doc. Okay, when I say the chunk is the length of chunk, we'll see how many chunks are created. So 215 chunks have been created. Now, after creating chunks, we need to get the textual data into the embedding. So for that, embedding, so from LangChain dot embedding, import open embedding. Information embedding is equal to open embedding. Okay. Then we need the vector store. We'll use the Chroma, so we'll install it. Pip install Chroma DB. We need to run it again, as our variables may be locked after restarting the session. We created the chunk, used embeddings of the OpenAI. Now we will import the Chroma. So from LangChain, dot vector store, import Chroma. Suppose I mention DB3 and Chroma from document. I'll mention the chunk, then the embedding, and the process directory. I'll mention DB. Okay. Now when I mention retriever, now I want to retrieve the document. So DB3 as retriever, and I'll not pass any parameter. And when I mention length of retriever dot invoke, and just mention the question, what is this paper about? Okay, that is the question. Now I want to see how many documents it retrieved. When I run this, so it has retrieved 4 documents. Okay, now I'll mention again the retriever PB3 has retriever, and here I'll mention that I want this document, file unlock. Okay. Suppose I mention K, that is a document, and I'll mention 6. Now see the difference. Previously, I have not mentioned that how many documents I want to retrieve. At that point of time, I retrieved 4 documents. Now this is the default one. Always remember, whenever you don't mention any number of documents, it will retrieve 4 documents. And now here I have mentioned that I want 6 documents. Now we'll see what is the difference. Now when I say length of retriever dot invoke, and I'll ask the same question. Okay. So now it has retrieved this document. In this way, we can change the default is 4. Okay. Now we can also mention the third type. I did how we want to get the similar document. So in this we have also the similarity, where it basically goes with the cosine similarity. So we'll see that one also. I will mention the retriever again. retriever is equal to db3 as retriever, and here I will mention the third type. The third type I will mention it as similarity. Now this is the default one, but I will still mention it. Even if I have not mentioned, it will go with the process similarity, and I will here mention the third verb. And I mentioned 6. So it will go with the cosine similarity. For retriever, always remember, for retriever, the third type by default is similarity. By default is similarity. Similar, okay. And that is the process similarity. And next is the k, which is by default. By default, it is 4. So if I don't mention any k value, it will give 4 documents. And if I mention k as 6, it will give 6 documents. That is about the retriever. And what is k? The maximum number of documents to retrieve. I'll mention the k definition also. Maximum number of documents to retrieve. Okay. Now we'll see what is the similarity. Similarity. Now it gives the most similar k document. Similar k document, which is the cosine similarity. Okay. Now next in first type we have MMR. Now what is MMR? It is the most relevant k document. Okay. It is the most relevant k document, and which is the maximum marginal relevance. Okay. Then we have the score threshold. Score threshold, which is to retrieve documents that have similarity larger than threshold. If you use to retrieve document that has similarity larger than threshold. Okay. Retrieve document that have similarity larger than threshold. Now we'll see one by one. Suppose I will mention the retriever db3 as a retriever and here I will mention the first type as MMR, which is the maximum marginal relevance, which gives the most relevant k document, and here I will mention the first work k. I will use value as 6. Okay. And I'll ask them same question. So we'll get the single document. I check the length. We got the single document, but using the MMR, first type is MMR, which is the maximum marginal relevance, and it gives the most relevant k document. Now, if we see more the definition, now relevance basically, now we see MMR. Now it stands for maximum marginal relevance we know, and it is a smart retrieval strategy that helps balance relevance as well as diversity. So it balances two factors. First one is the relevance. So relevance is what document most related to the query. Okay, that is the relevance. And what is diversity? Second is diversity, which avoid repeating similar content. So duplicates are avoid duplicate document. That is the MMR. Now we'll see the similarity. I will see the similarity core threshold, which is the used to retrieve document that have similarity larger than the threshold. Now in similarity core threshold, similarity core threshold. It is a filter that ensures only comes with a minimum similarity score are returned by the retriever. Okay. So basically, it helps avoid irrelevant results. If a document is similarity score to the query is below the threshold, it's discarded. One more thing is it helps avoid irrelevant results. Irrelevant results. Okay, and it returns only results which are above the core which we have mentioned. So we'll see that when I mentioned retriever is equal to db3 as retriever, and here I'll mention search type as the similarity for threshold. And I'll mention the search box. I'll mention the core threshold, and I'll mention the core threshold as 0.9. Okay, and then the relevant document for that I will mention k from 1. When I ask the same question, so we got warning that no relevant doc were retrieved using the relevant core threshold 0.9. Now I will do it 0.8 till we got mention 0.7. Then we didn't get, I'll mention 2 documents. I'll run it till 0.6. So when I have core threshold is 0.6, then we get the 2 documents. In this way, we can use the similarity score threshold and we'll mention the score threshold that is 0.6, 0.7, and it will basically filter out and see which are more relevant, and then we'll give according to our profile similarity. Now next, now we have seen the 3 types. We have seen the MMR, then we have the search type similarity. Okay, we have seen search type similarity, then we have seen the MMR, then we have seen the similarity score threshold. Okay. Now we will see the next retriever, that is the multi query. Now suppose in multi-query, I ask one query, and according to the query, we get in simple what we can say retriever. I ask a simple question like I have asked here, what is this paper about? And according to this question or the query, it has generated the or we can say gathered the document present in a vector store. Now, what if I want our answer to be more accurate or more related to our content? So at that point, we generally go for multi-query retriever. Now, suppose I ask in this multi-query retriever, what is this paper about? Now, my question is, what is this paper about? Now, I have asked the same question. Now, it will generate 3 questions. It will generate 3 questions based on the single question, and each question which are generated. So we will pass these 3 questions to the what we can say towards the retriever, and it will get the what we can say the relevant document. First query will get the related document from the retriever. So we have number of documents for the first question. For second question we have document. For third question we have document. And after getting multiple documents from these 3 queries, we will basically use the LLM to generate them as answer. That is the multi-query retriever in the LangChain. We will see, for example, from LangChain dot LLM and LLM equal to open it. Suppose I ask print I use LLM and say create 3 new questions from the given question. Okay. And my question is 10, which is What is this paper about? That is my question. So we created 3 questions. Now we see the working of the multi-query retrieval. Okay. So first step will be LLM will generate more queries from the single query. Whatever the single query we have there from the user, it will generate more queries. And these queries are similar to the original question. Generated queries are similar to the given question. Okay. Now second would be for each generated question, we will retrieve document. Retrieve document. And third step would be we will feed unique retrieved document with the. So this is the working of the multi-query retrieval. See the implementation part. Retriever equal to db3 as a retriever. System for retriever. Now from LangChain or retriever or multi-query import multi-query retriever. I say multi-query retriever. Mention multi-query retriever from LLM. I'll mention the retriever, one to retriever, and I'll mention the LLM. Okay. Now I'll ask the same question. Thank you, retriever dot to ask what is this paper about. So we got 8 relevant documents generated by we basically created multiple queries from the single question. Then what was the first step? LLM will generate more queries. So whatever the query we have asked, it will generate more queries, and the generated queries will be similar to the given question. So all the queries which are generated by the LLM will be similar to the question, that is what is this paper about. Now the second step would be for each generated question, we will retrieve document. Whatever the number of queries has been generated, for each query, we will retrieve document. And after retrieving document, what we'll do, we will feed the unique retrieved document to the LLM. That is the working, and how much we got, how many documents we got after retrieving. We got the, after passing it to the LLM, we got the 8 one. If I have get retriever dot invoke, what is it? Paper about. So this document we got second. This is the multi-query retriever. Now, next we'll see the parent document method. Okay. Next is parent document method. Now, in this method, suppose we have an original document. Okay. Now, what we do, suppose in this original document, we have original document. Okay. Document, and I split this original document into 4 different parts. Right. I divide it into 4 different chunks. Now, for each chunk, 4 different chunks, for each chunk, I will create 2 small, we will create 2 chunks. So in this way, what we have done, first of all, we have from the original document, 4 different chunks are created. Okay. Now in these 4 different chunks, for each chunk, we will create another 2 chunks. Now these 4 different chunks would be the parent, suppose. This is the parent. And for each parent chunk, we will create 2 chunks and we will call them as child chunk. So that is the parent document method. Now, why we are doing this, so we'll understand that. First of all, the smaller chunks, which are this one, so smaller chunks will give better retrieval, right? The smaller the chunks, we will understand more the context, so we will get the relevant. So smaller chunk will give better retriever, and it is because of redundant info. That is use of smaller chunks. And what will be the use of larger chunks? That is the parent chunk. I'll mention it child. And what about the larger chunk? Parent. It will provide. It will provide better context. Okay. So child chunk will give a better retriever because of redundant info, and parent chunk will provide better context. So in this way, we'll see the splitting more in detail about document. Then I have parent chunk one, okay, parent chunk one. Then I will have child chunk one, and then I will have child chunk two. Okay. After that, suppose I have parent chunk two, I will have child chunk three, child chunk, child chunk four. Likewise, now, okay. So in this way, suppose I want to, suppose I created from original document, I have created two chunks. It is the parent chunk one and parent chunk two. Now, after that, parent chunk one is being splitted into again two parts. That is the child chunk one and child chunk two. From parent chunk two, I have created child chunk three and child chunk four. So in this way, the parent document method works, and we saw the main use here. That is the smaller chunk will give better retrieval because of the redundant info, and the larger chunk it will provide better context. Okay, now we'll see the working, how it works. The first step would be in parent splitter. In parent splitter, we will get larger chunk, right? In parent splitter, we have the larger chunk. Then second step is we will further split each chunk into smaller chunk, into smaller chunk. Third step would be retrieve smaller, that is the child chunk from our database. And fourth step would be we will give larger chunk from which the retrieved chunk is created. Will use larger chunk from which the retrieved chunk is created to the LLM. That is the working. First of all, from the original document, they have created two chunks, big chunks, suppose parent chunk one and parent chunk two. After getting these two splitting, what we did from each parent chunk, we then again splitted two chunks. We created two chunks, that is the child chunk one and child chunk two. Same we did for the parent chunk two. We created two chunks, that is the chunk three and chunk four. Now, while retrieving, we'll retrieve only the child chunk from the database. So suppose I got the answer for my query in child chunk two. So I will not pass this to the LLM. I will pass the parent chunk one to the LLM from which it was created. That is the working. If I got the answer, or if I get the retrieve from the smaller chunk, if I got the answer from the child chunk four from the database, and I will pass the parent chunk two to the LLM to get the final answer in the human readable format. That is the working of the parent document method. I will see the implementation part. I mentioned of parent splitter, or the recursive character text splitter, and here I'll mention the chunk size equal to suppose 2000, and I'll mention the chunk overlap. equal to 54, right? I'll do it for the child Twitter. Child Twitter recursive character text Twitter animation chunk size chunk overlap equal to 0. Okay. I'll make a new database. db2 is equal to Chroma. I'll mention the collection name. Collection name. I'll mention it as parent child. Parent child. I'll mention the embedding function as embedding. Okay. I'll mention the storage from LangChain dot storage. I'll import the in memory store equal to in memory store. Now this is used to store the parent. Always remember it is used to store the parent chunk. Then from LangChain dot retriever is the import parent document retriever. And the parent retriever your parent document retriever. I'll mention the vector store. The store will be the db2 which will be used now to store. This will be used to store embeddings of smaller chunks. Embeddings of smaller chunks. Then we have the doc store equal to store which is used to store larger chunks. Then we have the child splitter equal to child splitter and parent splitter equal to parent splitter. We'll say parent retriever splitter parent retriever and we'll say add document and I'll mention the doc. So I say parent retriever dot get relevant document and I'll mention suppose attention. What will happen? I'll get the relevant document. Now we'll see the length. We have the 4 relevant documents according to the query which you have passed, that is the attention. So that is the working of the parent document method and also the implementation part. So hope you guys understood this retrievers, different types of retrievers we use. We have seen first of all, we have seen the search similarity or search that we have seen the similarity. In similarity, we have also seen how we could get the relevant document. And we have seen the MMR, that is the maximum marginal relevance. And we have seen the score threshold, which retrieves document that has similarity larger than threshold. In MMR, we have seen it is only documents most related to the query are retrieved and it avoids repeating any similar content. Likewise, in similarity score threshold, so it is a filter that ensures only chunks with minimum similarity score are written by the retriever. It helps avoid irrelevant results. So to avoid duplicate of the any or avoid repeating similar content, we use MMR, and to avoid irrelevant results, we use the similarity score threshold. We in this we saw how to use the score threshold or the K. Now K is what? K is the maximum number of documents to retrieve. And after that, we saw multi-query, how we were passing multiple queries using the single query, and by that we were getting the more accurate answer and trying to retrieve. We saw the working of it. We implemented it. Then we went for the parent document method, how we created different chunks. After creating the parent chunks, how we created the child chunk, and how would we retrieve the document, parent document, how child we were able to store the child chunk embedding into the vector store. And for parent chunk, we are using the in-memory store. So that is the parent document method, which was very useful to what we can say to retrieve chunks which were more relevant. That is the parent chunk method. And I hope you guys understood the total working of the different types of retriever, and I want you guys to practice more and do different examples or different PDF to practice on it. And I will guys see you in the next section with the new topic. Till then, bye.